In this video, we're going to start talking about annuities. And an annuity is a steady stream of payments. Now, some annuities will have a fixed number of payments, and then there are other annuities that are called contingent annuities that do not have a fixed number of payments. On the reference sheet, you'll see some more shapes. And just like before, I have drawings to help you determine which table to use in the student handbook. And also, just like before, I'm going to look at this drawing as if it were a timeline working left to right. So when you see these lines on the drawing that looks like steps, I want you to think of those as the payments. Each step is a payment. And as we work left to right, if those payments are going up, that means you're saving money and you're going to grow your account into a bigger lump sum. Now, if you're looking for what that bigger lump sum would be after saving up all those payments, then you're going to use table 13.1 in the student handbooks. So that would be the next column. Okay, so just like before, I'm going to show you how this works by hand, and then I'm going to show you how you can use the tables. So doing this by hand, we have an example where we have an ordinary annuity, and we're going to be making payments of $3,000 annually for 3 years. And it's going to be at 8% interest. Payments are $3,000. And this specifically says an ordinary annuity. Now, an ordinary annuity is when you make the payment at the end of the period. So in this case, since we're making 3 payments of $3,000, so at the end of each year, since we're doing this annually, we would make a payment of $3,000 to save in the bank. Okay, so we're going to have the beginning of year 1. We're going to have $0 in there because we make the payment at the end of the period. So at the end of year 1, we make a payment of $3,000. So it hasn't earned any interest yet at the end of year 1 because we just put that payment in. At the beginning of year 2, we have the previous balance from the previous year of $3,000. At the end of year 2, then we can process that $3,000 for interest for that second year because now it's been sitting there in the account for a year. So we're going to find the interest by finding 3,000 times 0.08. We're going to get $240. So at the end of year 2, we have the $3,000 in there from the previous year. Then we have the $240 of interest. But then remember, at the end of every year, we make a payment of $3,000. So that's going to be a balance of $6,240. Because we have the $3,000 that we put in the first year, we have the $3,000 that we put in at the end of the second year, plus the interest that was earned in the second year. So now at the beginning of year 3, we're going to have a balance of $6,240. At the end of year 3, we want to use our balance to calculate the interest. So the interest is going to be our previous balance times the 0.08, which would give us $499.20 for interest. But we also have the $3,000 payment that we make at the end of every year. So our balance is going to be $6,240 plus the interest that we made over the third year plus our next payment, which is $3,000. So when we add all that up, at the end of year 3, we're going to have $9,739.20. So that is an ordinary annuity. That's when you make the payment at the end of the period. Now, to use the tables to do it more quickly, we're going to do the same thing we did before. We're going to find the rate per period. We are going to find the number of periods. And we're going to find the table value. And what we're going to do is once we find the table value, we're going to multiply the payment by the table value or the table factor, and that will give us the accumulated balance at the end of the time frame. So working the same problem that we just did above by hand, step by step, we're now going to do that same problem using the tables. So if we have an annual annuity, and the rate is at 8% per year, since each year is considered a period, then the rate per period is going to be 8%. Since we're doing this annually for 3 years, this is going to be 3 periods. So now, because this is an annuity and we're trying to figure out what lump sum of money that we're trying to save up at the end of the time frame, we're going to use table 13.1. So when we look at the table 13.1, we want to find the page that says 8%. We want to go down to the number of periods. It says 3 periods. We want to make sure we're looking at the column that says 13.1. When we do that, we get a table factor that is 3.2464. So that means we're going to take the payment, which is $3,000, times 3.2464, and when we multiply that out, we're going to get $9,739.20, which is exactly the same thing we got when we did it up here by hand. Okay, the next example is an example of annuity due. Annuity due, the payments are made at the beginning of the period. Okay, so at the beginning of year 1, we're using the same problem that we did before, an annual annuity at $3,000 for 3 years. So, because this is an annuity due, we are making the payments at the beginning of the period, which means at the beginning of year 1, we're going to make our first deposit of $3,000. Then at the end of year 1, we're going to find the interest for that first year by taking 3,000 times 0.08, and we're going to find that that's $240. So that means at the beginning of year 2, we're going to have a balance of 3,000 plus the second payment for the second year, because we make the payments at the beginning of each year. So 3,000 from the year before's payment, and then another 3,000 for the beginning of the second year, plus the interest from the first year, which would give us $6,240. So then at the end of the second year, we got to find the interest. So to find the interest, we're going to take our previous balance, which is $6,240, and multiply by 0.08. When we do that, we get $499.20. So then at the beginning of year 3, we have our previous balance, which was $6,240, plus the interest we earned, plus the next payment that we make at the beginning of every year, which would give us a new balance of $9,739.20. At the end of the third year, we got to find our last amount of interest, but since it's the end of the year and we're stopping here, we're not making another payment because we only make payments at the beginning of each year for 3 years. So we're making 3 payments. Okay, so we're going to take the previous balance, which is $9,739.20, and multiply it by 0.08. And we're going to get that interest is $779.14. So our balance at the end of year 3 would be $9,739.20 plus the interest, which is $779.14. So our balance would be $10,518.34. So notice with Annuity Due, we have the same number of payments as periods, but we get an extra period of interest, right? And when we did the ordinary interest up here, let me scroll up, we had interest calculated here and here. And that was because we were calculating it based on the end of the period. When we have an annuity due, we do it at the beginning. So that gives us an extra period of interest. But we're still making the same number of payments. So when you look at this annuity due, I'm still making 3 payments. 1, and then this one here, 2, and then this one here. It's just that it's made at the beginning. So now when we use the tables to calculate an annuity due, what we're going to have to do, because with the annuity due, we get an extra period of interest without making an extra payment. What we're going to have to do is when we look up the table value, we're going to have to add an extra period, but subtract off an extra payment. The tables that are given in your student handbook are made for ordinary annuities. They're not made for annuity due. So you're going to have to figure out what that annuity amount is with an extra period, but we don't want the extra payment. So we subtract an extra payment. So it says find the value of an annual investment 3 years for $3,000 at 8%. So that means I'm going to have the rate per period is still going to be 8% because it's once a year. And so that 8% is going to cover the entire year. But the number of periods is actually going to be 4 because we have 3 periods plus 1 extra period for the extra period of interest. And then what we'll do is we'll subtract off a payment. So when we look this up in the table, we're going to look up on the page that says 8%, and we're going to come down to where it says 4 periods now because we're doing an extra period of interest. So that table factor is 4.5061. So I'm going to take 3,000 times 4.5061, and that's going to give me $13,518.30. So what this represents is 4 periods of interest with 4 payments. But we only want 3 payments. So I'm going to subtract off that extra payment. And when I do that, I get $10,518.30, which is what we got up here. It's a little bit off because the tables use rounded values, but it's close enough that we can see that it works out the same. Okay, let's do one more example, but we're not going to do it by hand this time. Now this says ordinary annuity, so we can just use the tables without having to worry about adding in an extra period and subtracting off an extra payment. Now it says the value of an investment after 4 years on an ordinary annuity of $5,000 is made semi-annually at 4%. So the rate per period is going to be 2% because that 4% is going to get split up into 2 periods per year. Then the number of periods is going to be twice a year for 4 years, which would be 8 periods. And since this is an annuity and we want to see what the value is at the end, remember we're making payments of $5,000. So this time frame from here to here is going to be 4 years. So twice a year for 4 years, we're going to be making payments and we're saving up a lump sum of money. The question is asking, what is that lump sum of money going to be at the end of the 4 years that we've saved up? So we're going to use table 13.1. So we're going to look at the page that says 2%. We're going to go down the column that says 13.1 and find the number of periods, that's 8. We're going to get 8.5829. So we're going to take $5,000 times 8.5829, and we're going to get $42,914.50. So this is what's going to be in the account after the 4 years. Now, here's something to think about. How would we calculate the interest? Well, what we need to do is we need to take the total accumulated balance and subtract the money that we put into the bank. Whatever the difference is going to be the interest. So we're going to take 42,914.50 and we're going to subtract the amount of money that we put in. Well, how can we figure out how much we put in? Well, if we made payments of $5,000 8 times, because there's 8 periods, that's going to be $40,000. So when I subtract, whatever's left over is going to be the interest. So the interest is going to be $2,914.50.